And so welcome to this session of the Fusion Hackathon. And this is probably the last formal presentation on really the Fusion API. And the other ones will be more on submitting your app for the App Store. There's one that's still open. So if you have suggestions, we could still cover some topics. But right now, this is the last one that I'll be presenting probably. And so this one already, I've just kind of picked some odds and ends things that either wanted to go into more detail that we've talked about before or things that haven't covered at all. And so the first one is go a little bit more into what's in the help. And I mentioned there's this new help format and the old help format. And you want to use the old help format. It just works better. And a way to get to the new help format, if you're inside Fusion and go to help, that it'll take you to the new help format. But to get to the old help format, an easy way is if you just Google for old Fusion help format, and the first link that'll come up is a link to this Mod the Machine blog post that I made, and that'll have a link to the old layout, the old format. And once you go there once, you could create a favorite for it, so then it's quick and easy to get to after that. And so let me got a few slides here that just talk about what's in the help. I'm going to skip through the slides real quick and just go to the help itself and demo that. But first, while I'm here on this slide too, just to show you what's in the help. So it's quite a bit of work to manage. To manage all of this because there's 501 objects, so they all have topics, and then we're 5,500 functions, so all of those have topics, and 70 enums. There's 56 samples, so there's quite a bit of content there. And so let me bring up the help. And so this is the older format. The newer one has a lot of white space around it, and it doesn't support going back to use the browser to go back to the previous content. There's a couple of formatting things that aren't quite right, so this newer one is just friendlier to work with. So, all right. So over here on the left side, there's the big table of contents, and then there's this programming interface section. And the first topic in that is this welcome to the Fusion 360 API. And this is probably something where you've been there once, you don't need to go again. But so it's just a general overview, but it does have links to some other topics, some other resources. You can get to the PDF for the Fusion Object Model through here, links to the blog, the discussion groups, and this has, I'm going to talk about it a little later, there's also a GitHub site, and for the next version, this topic will have a link to that too. And then there's a what's new topic, which changes with each release. So this is good just as new releases come in, just to take a quick look, especially at the top. So we'll highlight any big what's new items there, kind of general areas where maybe there's been a lot of work, but maybe more important is any changes that might impact you. So maybe Fusion changed, and so the API had to react to that, and something that might affect your code. So and that'll be posted in this what's new with each release. Then we have the user's manual, and you can expand that in the table of contents to see what's there. You can also just click on the user's manual, and it'll bring up the various topics. So these are kind of overview papers of these different topics, and so it's most of the stuff that we've gone over this last few sessions. So how do you create a script or add-in? Some basic concepts, what is an object model, what are collections, all that stuff. User interface, how do I add buttons into the user interface, how do I create commands, use events, document an assembly structure, geometry, solids, surfaces, units. We haven't talked about this, so this would be a good one to go look at. It's understanding how units work inside Fusion. And then these next three, you should go and read the one for the language that you're using, because it has some language-specific things you want to be aware of. So just ways to do things, and so that this is a good one. And then I have mentioned this before, that any of the APIs that let you do selections you can specify filters of what you want to have picked, and so here's a list of the different filters that are supported. Right, so that's the user's manual, and then there's the reference manual, and that's where all those 500 objects and 5,500 functions and stuff are documented. So if I expand on objects, then there's an alphabetical list of those 500 objects. And if I go to any one of those, then there's a topic for that object. And so it tells me if it's derived from something, and everything in Fusion, every object is derived from this base class, this base object. And but other things, let's see, will be derived from other objects. So let me find one that would. So here's a pipe feature, and so it's derived from feature. So I can click on that, and then feature is derived from base. So I can see that derivation hierarchy, and I can just jump back to wherever I am using the back arrow, and this older format helped. Inside each of these topics, so this is a topic for an object. So it has a description, it lists the methods, the properties, and if it had events, it would list those. It also shows me what properties in the system return one of these objects. And so this loft features collection object is just returned by the loft features property on the features object. And I can click on that and go right there. All right, so that's the object, and then each object, and then it lists the methods and properties, and then so for each method and property, there's a topic for that. And so here's for this property, again, a description, has what its parent object is, so I can click on features and go back to features. So here's a method. Methods and properties are somewhat similar. So here, let's go back to properties. So it tells me what its parent object is, a description, and it has this syntax area. And so this shows what it would look like to call this in Python, JavaScript, or C++. So you've got the three tabs. And in a lot of cases, you can almost cut and paste this and maybe just have to replace like this variable, this elliptical cone _var. So as long as that's a variable that's referencing an elliptical cone object, and so if you have that up in your code where you've gotten an elliptical cone and you replace this variable with that variable, I mean this could be cut and pasted into your code. And that's very useful with events. So if I go to, say, command, which has a lot of events that it supports, And so if I go to this event, here's all of the code really that's needed to handle that event. And I can, like say, pretty much just copy and paste this in, replace a couple of the variable names, and then just use this as is. So let's see, let's go back to some other function. So here we're back to some function. So it shows me the syntax, what the return value is from this. It's described what the input parameters are. So that's, you can see these as the input arguments. So I've got input entities, and access, and those are described down here. And then if there are any samples that demonstrate this particular method, then they're listed at the bottom. And then it shows what version of Fusion this particular function was introduced. So that's the reference manual. So the objects are listed. Here's a list of the enumerators. So just a quick list of each one and a short description. And then, so as I showed, the sample programs are linked from the functions that are used in that sample. And then there's also the same sample programs are presented here, just in this this hierarchy structure. So you can get to samples either way. And so each sample, so most of them are shown in JavaScript, Python, and C++. And they should, for the most part, and if they don't, it should say in the description, but you should be able to just copy and paste this, create, say, a new script, and copy and paste this and replace all of the existing script code, and then run it, and it should run. And most of these, again, unless it says, shouldn't have any pre-existing requirements. They're completely standalone. And so, say for example, if there's a sample that shows creating a fillet, it probably starts by creating a new document, building a box, and then adding a fillet to that box. So it doesn't have any dependencies on. It's not expecting a certain model to already be there, for example. So. All right, so that's the help. Right, and here's something I wanted to demonstrate. Is inside Fusion, and it's meant more for internal use. For debugging, if you go search the Fusion help, it won't even talk about this at all. But it can be useful when you're programming Fusion. So if you go to the File menu and under View, and then do Show Text Command, and then this window will pop up at the bottom, and I'll demonstrate this in a second. And then you want to change in that lower right hand corner, you want to switch it to Python. And this can be useful to do some kind of quick playing around with the API and not have to really write a script to just check something pretty quick. So I've got an existing file open here that I built just a minute ago. All right, and I've already done the display, so I see my text command window, and I've switched to Python. And now I'm going to write my little program in here one line at a time, kind of. But so I'm going to import addins.core, from addins.core import star, from adsk.fusion import star. If I spell it right. And then just like I would in any script or add-in, I need to get the application object. And I do that just the same way as you see the first line when you create a new script or add-in. So I call this static function get on the application object. So now I have the application, and I can just type in app, and it shows me that that variable called app contains an application object. So I know I've got it. And if I'm wondering what app supports, I can use this Python function called dir, and I want to do a dir on app. And here are all the methods and properties that app supports. So there's active product, that's what I want to use. So I'm going to say design equals app.activeProduct. I can again see, so DES is referencing a design now. And I want to get the root component. And I can use this to do some quick playing around. So I want to see how many sketches are in here. So root.sketches.count. There's 2 sketches. Right. I could even do, so I'm going to get the first sketch. So I could do item 0 sketch curves sketch line. Well, let's just do sketch curves count. So how many curves are in that first sketch? Whoop, and I have some wrong. Sketch curves count. So there's 7 curves in the first sketch. Or maybe I'm new to parameters and want to kind of see how parameters work. And so on the root, so let's do dir root. So here's all the things that a component supports. And one of the things I can see here is model parameters. So let's say MPS for model parameters equals root.model parameters. And let's see how many model parameters I have in this component. So there's 8. And so I could do item 0, or Python supports, you can just use this syntax. So the first parameter is D3, second one's D4. So let's play with the D3. So its value right now is 4. So that's going to be in centimeters. When I get the value, that's always in internal database units. Or I can get the expression. So that's the string that the user would see in the dialog. So that'll depend on the current units. So if I change my units now to inches, and I get the expression again, oh, I guess it's set in the parameters dialog. Let's go look. Yeah, its expression is 40 millimeters. So that's the string I'm getting. So it's overriding the units and being specific to what units it should be. So if we do 1.6 inch, well, just 1.6, that's interpreted as inches. Now let's go back, get the expression. So 1.6 inch, the value is that in centimeters. But let's go back to the expression. And I want to change it. And this takes a string, so I want it to be 5. So that'll be 5 inches since that's the default unit and I'm not specifying a unit. And there my model changes. change it to 1. And so, it's not, you don't want to write a big program here, but it's a way potentially to do some quick little testing and prototyping without having to create a new script. So just an option that you wouldn't know about otherwise. And then once you've kind of prototyped some little thing, see it works, then you can copy and paste out of your window into your program and use it there. So. All right. So a few things that I found are kind of gotchas that I get stuck on, and especially at first I got stuck on quite a bit, is when you're doing selections. So either I put a selection command input into a command dialog, or I'm using the select entity method, or I'm just getting from the active selection set, I'm getting back an object. In all those cases, what I get back is a selection object. And what I would write code that would just get that object back. So maybe I'm picking a face and going to do something with it. So I would get the selection back and then start calling face methods on that. And then they fail. And the reason is what I get back is a selection object, not a face. And then what you have to do is on the selection object, there's a property called entity, and then that gives me back the face. So the selection gives me back the entity that's been selected, plus it provides some more information too. So just from Inventor, I was used to getting the object directly back, but you just have to do this extra step of calling the entity property. And just you want to double check what types are being returned by functions. So to go to the help, and just verify that. So if you've got a function and you're getting something back and then it's failing after that, is again just double check what you're getting back in the help or in the console window. Check and see what you've got, because that's a common thing, is you're expecting one thing, just like this selection thing, you're expecting one thing, but then it's something else. Like you might be expecting to get back that some single object, and it's really returning an object collection because there could be multiple entities. Another thing, so not so much a gotcha, but just a tool is where are my programs? And you can go to the scripts and add-ins dialog and pick any program, and then you can expand the details at the bottom, and then it will show you the full path to where that program is. And so most programs, if you just say create a new script or add-in, it's going to create it in this kind of deep directory that you can see listed there for that full path, but in app data, roaming, Autodesk, Fusion 360, API add-ins or scripts, and it's buried down in there. And so this can be a reminder just where that directory is. But you can also, your programs can exist anywhere on your disks. So if they're in this location, Fusion is going to find them automatically. So at startup, it will go look in these directories and find your add-ins or scripts and then list them here. But you can, let me just show this real quick. Yeah. If I go to the scripts and add-ins dialog, there's this little green plus, and I can click on that and I can browse to anywhere on my machine and load a script or add-in from that location, and then Fusion will remember it for subsequent sessions. So they don't have to exist in those directories. And anyway, that's the scripts and add-ins dialog is a way to remember where that source is, or to find out where it's at. So some tips with Python, and I mentioned this in a session before, but I wanted to go over it again because it's really useful. So let me bring up a Python script. Just any simple one will be fine. And yeah, so this is a good example right here. So, and I'll make the code a little bit bigger. All right, so this is getting the application object. And especially if you're coming from Visual Studio, you're very used to using and kind of depending on code hints to tell you what properties and methods are available on an object, and then what the arguments of a function call are. And you tend to, if you don't know about this casting, you don't get that when you're using Python. And so here, so Python is an untyped language, so we're not telling it, when we create a variable, we're not telling it what type that is. But Spider is trying to figure out what types and infer types so it can show some code hints. And so for example, here where we're getting the application object, so there's some files that the Fusion API supplies into Spider that describe the API. And so Spider knows that this get method on the application object returns an application. So now when I do app dot, I get good code hints. So these are all of the things that the application object supports. And so that's good. And now, so if I do, so I'm writing this line, app design equals app dot, and there's active products. So I get that. And now I want to use design. So we come down here, design dot, and I want to call root component, and I don't see root component here. So it's not showing me what I'm expecting, and if I get even lower than that, so let's just say I type it in because it is valid. And so now if I do root component dot, I get almost nothing. And this isn't based on its knowledge of what the API is, it's based on what I've typed in before for root component. So it's just kind of learning from what I've done. So this isn't good information that I'm getting here. And the reason for this is if we look in the help, and so we've called that. So we want to go to application dot active product. All right. And so this says it's a read-only property whose value is a product. So this is returning a product object. And if we look at that, here's the things that a product supports: is valid, object type, parent type. And but there are some things that are derived from product, and design is one of those. Well, right now it's the only one. In the future there'll be CAM and some others that will be there. So design is the one that has root component and all this other stuff. And so Spider, so I'm calling app.activeProduct, and that's typed to return a product. And so that's what, when I do dot, design dot, it's showing me all of the stuff that a product has. But I know that I'm really getting back a design, but there's no way for Spider to know that. But I can kind of help Spider know that by doing this. So this is where the design object is defined, and then there's this static cast function. And so this doesn't change how my program runs, but all it's doing now is Spider knows, oh, this variable is going to be a design object. And so now when I do design dot, I see all of the stuff that's on a design object. And so now I can get root component. And now when I do root component dot, I get all the stuff that's on a component. because Spider knows that from a design object, if I call the root component property, that returns a component object. So it's able to tell me all the stuff that's on a component. And so if I call sketches, and it knows sketches returns a sketches collection. So if we do sketches dot, I get all the stuff that's on a sketches collection. So this can make, I think, programming a lot faster. To me, it's worth doing that little extra typing to do the cast, so I can get these code hits, and it saves me from having to jump back to the help and have to see what's supported and just exactly, you know, how it's spelled and what the arguments are. So for example here, add, and so it shows me I need a planar entity and an occurrence. It doesn't show me what's optional or not. That second one is optional, but it doesn't show me that. Anyway, so that casting can be a big help. This is another kind of gotcha and goes back to my tip on the other slide, is to double check your return types. So in Python, return values are returned in a tuple, and the first value in that is just the return code, so true or false, whether it succeeded or not, and the second one is the value. And so this is just a case where you need to be careful of what you're getting back, and you can see this in the help when you look at that the syntax where it shows you how to call it in Python, and it will show you that it's getting a tuple back and then how to get those specific values out of that tuple. So some couple of things, hints for debugging, is if you're debugging an add-in. So let me open up Spider here again. Oh, there it was. This isn't an add-in, but just a script. But I can start a program from inside Spider. So I can run this, or I can debug. So I can start in a debug mode. But for an add-in, I don't want to do this. I want to start my debugging by picking it in here and pick debug from the scripts and add-ins dialog. And then, so I can debug, I can stop it, so then I can go back into here and pick a running add-in and say stop. And then, so if I go make some changes to my code, and it doesn't have to be stopped when I'm making changes, doesn't matter, but I would then save my changes, come back here, stop it if it's not already stopped, and then start debugging again. So you want to start debugging from here and not from Spider. For a script, it doesn't matter so much, because scripts run and they're done, but add-ins run and they continue running, and you need to control that lifetime of the add-in through the scripts and add-ins dialog rather than from Spider, because it's really Fusion that needs to control that. And this is another thing. Originally, I got caught it a few times. I was debugging a script, you know, and there would be bugs in it, but I would get to a point where Fusion just seemed hung up. So Spider wasn't responding anymore, Fusion wasn't responding anymore, and I just go to Task Manager and kill everything and start over. But what was happening is there was a message box that I didn't see, and so everything's just waiting for me to click that message box, so to free everything up. So it's this mobile dialog sitting there. So just if things look hung up, go look and see if you've overlooked a message box. And put try statements around your code, because when you're running, and if an error hits it, it'll just jump out of that function, and you won't see any errors. You won't, you don't get any indication really that an error happened, other than you don't get the results that you expected. And so Fusion, for errors, it's asserting, and so when assert happens, it'll jump out of a function and then just continue running. But if you put a try statement in that function, then when that assert hits, then it'll jump out and display a message box with the error, so you can cache those. This topic has come up a couple of times, and I just wanted to address it here a little bit. So to create your user interface in Fusion, of course you can use the command dialogues, and that's what you should use if you can. Then everything looks like Fusion. Your program fits right in and looks like all the other Fusion commands. And for anything else, right now there really is no good solution to do other more complicated or some other UI that the command dialog currently won't do. And we need to come up with something, but if you really require some other dialogue, then we'll probably have to wait. Right? The only other solution right now is to use C++ and create a dialog in MSC for Windows, and then write Mac specific code for Mac and use Cocoa to build the dialog there. And nobody really wants to do this. They want to do one UI that can work on both platforms, but right now this is the only solution, and there's nothing specific, nothing about this that has anything to do with the Fusion API, right? You're just using whatever Mac supplies and whatever Windows supplies to create a dialog. So it's really outside the scope of the Fusion API, and so we've looked at some alternatives and just haven't come up with anything that's feasible yet. So I've used a few samples as we've gone through this hackathon, and I'm in the process now of publishing those up, and was trying to figure out where the best place to put those is, and decided that maybe this GitHub site. So there's a Fusion 360 GitHub site, which you can see the link there for. And so it'll take you to this main page, and then it has some links. Let me go ahead and go there. So here's the GitHub site. And there's a link to a video, but what we've gone through in this hackathon has more detail than what that has. And then it has links to quite a few scripts. And so there's some that Autodesk has written, and then there's some that from outside Autodesk, and actually in some cases that these are Autodesk employees but outside the Fusion organization, so that's their personal GitHub site or GitHub account, and linked to programs they've written. But we could link to anybody's Fusion programs if we know about them. So this was kind of meant to be a one-stop place to find a lot of Fusion code. But so I'm going to put together all these samples. I think I'll just have one link. It'll just be Fusion Hackathon samples, and you'll go into that, and it'll be a directory for each sample rather than creating a new repository for every sample, because some of them are pretty small. But so you'll be able to access all the samples there. So I hope to have those up, at least start putting them up today even, and some of the bigger code I might take a little bit more time to clean up, but I'll be working on that. And so another thing, so this isn't actually available until November, what I'm going to show you here. So there's another major update scheduled for, and I don't remember the exact date in November, but sometime in November, I think the latter half. But something you want to be aware of with your add-in is how long does it take to load, because Fusion is going and finding all the add-ins at startup time and loading those. And so every time I start Fusion as a user, I get hit with how long it takes for all those add-ins to load. That affects how long it takes for Fusion to be up and ready for me to use. And but in the November update, you can do this, is set this environment variable to yes. So Fusion, every time you run it, it's creating a log file, but it's not that big. It's just some key information. But if I set this, it logs a bunch more information. So you probably don't want to have this on all the time, just because you'll bloat those log files. But you'll be able to set this environment variable, and then Fusion writes into these log files, and this is where they're located. So on Windows, this local app data, I'm not sure exactly where on Mac, but so down in Autodesk Fusion 360, and then you'll have your user ID, and then the logs directory, and then the file itself. And so here's an example of a real path. So your user ID is this mix of numbers and characters, and then that log file is some concocted name based on the date. And so all I do is set that app log for performance equals yes, and then I just run Fusion and shut it down, and then go look for that file. And what it's going to look like is something like this. So there's a bunch of stuff in here, but the section, then I could search for my add-in, and it shows me how long it takes for each add-in to run. So you can see most of these are, here's 0.006 seconds, 0.001 second, 0.298 seconds. So they're, just a few thousandths of a second to run, most of them. Some of them are a little bigger, a hundredth of a second. But so you'd want to check your add-in to make sure you're not taking a lot of time. And so the big thing, really all your add-in should be doing at startup is just inserting its UI. And then if the user actually runs your command, that's when you would want to start loading external libraries and doing any extra work that you need. So you don't want to be doing, you don't want to be hitting the internet or doing anything else at load time, but wait until the user actually has activated your command. All right, so that's it for what I had today. So that's the 15th. So on the 20th, you got the email that we moved the submitting your app to the App Store session for next Tuesday. And I don't know if we've decided, right, the real-time help for submitting your app was on the 30th. Maybe we'll do that twice, have that on the 22nd and the 30th. We'll discuss that and then send out another email. But so that's it for today. So if there's any questions. So you can, as in the past, type them in, or if you raise your hand and want to ask, I can unmute you. All right, looks like it's quiet today, so maybe that's it. All right, well, thank you for attending, and we'll see you next Tuesday. And have a nice day.